I'm Rikito Takai, and I was assigned with assignment 19, and I'm going to solve two problems using the comparison test. So the first problem is determine if the series n equals 1 to the infinity cosine squared of n divided by n squared plus 1 converges or diverges. So first, we're going to need to know what an and bn is. So an is cosine squared of n divided by n squared plus 1. And then bn would be 1 over n squared. So first we should take the denominator and check which one's bigger. So n squared plus 1 is obviously bigger than n squared. So if we put that in the back in the denominator, 1 over n squared plus 1 is going to be less than 1 over n squared. So if we put back the cosine squared, it's still going to be, an will still be less than bn because this 1 over n squared plus 1 was less than 1 over n squared. So now we need to look at the direct comparison test and see this first one. If series bn is convergent and an is less than or equal to bn for all n, then series an is also convergent. So now we know that bn is greater than an. We know that this is going to be all convergent or not. So first we need to check if bn is convergent. So to do that, we need to use the p-series test, which is theorem 11.3.4 p-series test. N equals 1, series n equals 1 to the infinity, 1 over n to the power of p is convergent if p is greater than 1, and divergent if p is less than or equal to 1. So let's just see this. So for bn, 1 over n squared, p is going to be 2 because n squared 2 will be 2. P equals 2. So we know that p is greater than 1, so bn converges. So bn converges, so the an, the series n equals 1 to infinity cosine squared of n divided by n squared plus 1 must converge because of the direct comparison test. For the second problem is true or false. The series n equals 1 to infinity, 1 over n to the power of 3 over 2 converges by comparison test with series n equals 1 to infinity, 1 over n squared. So first we have to determine the an and the bn. So the an will be 1 over n to the power of 3 over 2, and bn would be 1 over n squared. And we have to check the denominator, which one's bigger. So n to the power of 3 over 2 is going to be less than n squared. So if we put that back in the denominator, we know that 1 over n to the power of 3 over 2 is greater than 1 over n squared. So now we have to look at the direct comparison test and see the second one. If series bn is divergent and an is greater than or equal to bn for all n, then series an is also divergent. So this, if bn is divergent, we know that an will be also divergent. So we have to check if bn is divergent. So to do that, we can use the p-series test. The series n equals 1 to infinity, 1 over n to the power of p is convergent if p is greater than 1 and divergent if p is less than or equal to 1. So we can see right here, 1 over n squared, the p will be 2. So we know that 1 over n squared is going to be convergent. So that means that bn is convergent, so this direct comparison test doesn't work. So now, that's why it's false. The series n equals 1 to infinity, 1 over n to the power of 3 over 2 converges by comparison test is going to be false. So to find the an, if it converges or diverges, we can use the p-series test again and see 1 over n to the power of 3 over 2, p will equal to 3 over 2, which is p is greater than 1, which means 1 over n to the power of 3 over 2 converges.